Hello, you all, welcome to our lesson of chemistry practical. Today we are going to continue with our lesson of redox titration. I will show you the chemical reaction between potassium permanganate, sodium thiosulfate, and the liberated iodine from potassium iodide within acidic medium. So that is the second lesson. So you're welcome to proceed with our redox titration. Redox titration involves oxidation and reduction reaction. So today we have potassium. We have potassium permanganate. We have sodium thiosulfate. We have potassium iodide 10%, and then we have starch, and then we have sulfuric acid to induce acidic medium within our solution. Acidic medium is needed by potassium permanganate in order to make the correct reaction. That's why we use sulfuric acid. So we see the reaction. This practical, we have a reaction, but within each reaction it has two reactions. In case of procedure, the potassium permanganate this one will be in flask. Potassium permanganate will be in a flask, and we are going to add the sulfuric acid. We add sulfuric acid and the potassium iodide. So we add this one. We add the potassium iodide. We add the potassium iodide in order to get the iodine. And then we are going to add sulfuric acid within one solution. That is in conical flask. But this one, sodium thiosulfate, will be in a burette. Will be in a burette. That is a procedure. And we have starch. We are going to add after titration to identify the presence of iodine within a solution, or liberated iodine within a solution. Then after putting this in a burette and this in a conical flask, we have to titrate. This is 1, this is 2. We are going to titrate. Between liberated iodine with the sodium thiosulfate. Titrate this one, and this is liberated iodine. Then we are going to add starch. We add the starch. To reach out the boiling point. This one. That is the procedure can be performed. Then, after adding starch, we titrate again in order to get a colorless. Because the colorless means potassium permanganate or manganese for dioxide will be reduced and undergo reduction from this one to manganese 2. That's why we get it colorless. So the end point for this practical is colorless, and then our solution will be colorless. So let's proceed with how we are going to integrate the reactions. because when you see there is a reaction between sodium thiosulfate and the iodine, and then manganese oxide also react with iodine. But after reaction between manganese and iodine, there is liberated iodide from iodine, then iodide will react with the thiosulfate. So that is our lesson for today. Let's proceed with the chemical reactions one by one. Let's proceed with the reactions. We are going to use those procedures, then we create reactions. The first, we add potassium permanganate in a conical flask with sulfuric acid with potassium iodide. So let's see, it means will be manganese 4 oxide react with an acidic medium. Also there is iodine. The product was B, manganese oxide plus liberated iodine plus water. That is the reaction between this and this. So for this first reaction, we have to manipulate the half reaction, reduction, and the oxidation. So for this, we have half oxidation and half reduction. Let me proceed with the half reaction. Half reduction. Reaction. It will be this one, will be 4 oxide, 1 and acidic medium. This means will be this one, react with will be manganese 2, this one plus water. When we look this one, there is 4, there is 4. So here we put 4 and here will be 8. Those are balanced element. In case of ions, there is 5, there is 7, there is 8, here there is 1. So it is 8 minus 1, there is 7 ions. So, but here there is 2. So we have to add the area which there is more oxidation state or ions. So we plus 5 here electrons in order to balance our ions. So it means will be 8 minus, this is 5, this is 6. So 8 minus 6 will be 2. And here there is 2 ions. So that is half for reduction within this and this one. For this oxidation, half oxidation reaction will be iodine liberated to produce this one, iodide. So there is 1, that is iodine, produce this one. When we balance, you get here is 2, but the ions here is 2. But here there is no ion. So in order to balance, you have to add 2 electrons. So that is balanced. So for the first titration of this one, even this one, you have to find the overall reaction. This and this one will get the overall for the first reaction. Let's proceed with the overall reaction. So overall reaction between manganese, this was half reduction, and this was half oxidation. So we create the overall reaction. put this one. What do we consider here? We have to consider this and this one. This one and this one. It means this will be here, will be 5, and this one will be here, will be 5. So overall reaction will be this time, this one will be 2, plus this and this one will be 16H plus. But when this and this one will be 10, and this with this one will be 10. So this and this one will cancel. So the rest will be this one. Will be 10, the product. So this, that is over. So we go to the product. It will be 2 M plus this one 5 plus this is cancelled with this one. So there is still 5, 8 water. That is overall for the first reaction between potassium permanganate and the iodine. I think you have catch me how to manipulate from the procedure to chemical or balanced ionic equation. So this is net balanced ionic equation for the first reaction. Before adding starch, let's proceed with the second reaction. Okay, for the second procedure or titration, there was liberated iodine from potassium permanganate react with thiosulfate. The product here we have this one plus this one, sulfate. That is the product. So even this one we have to manipulate half reaction for oxidation and reduction. I think you see that one. So half reduction, reaction will be this one. Will be the sulfate is going to produce this one 6, 2. Here there is 2. These are balanced the element, but ions not yet, so we have to add here. Here there is 2, but here there is 4, so we have to add 2 electrons here, side. That is half for reduction of thiosulfate. Oxidation, half oxidation. There is this one about to produce iodine. Here in balance is 2, but these electrons are not yet balanced, so we have to add this side. So we have to add will be this one plus this one. That is half oxidation reduction for liberated iodide to this. Then even this one, how to find the overall reaction for this one in order to get the when we are going to combine overall for the first, you combine with the overall for this reaction to get a net balanced equation for this practical. That is our solution for this redox reaction. Overall reaction for this one, you have to look if there is no need of putting this one, you can remove it. Then you look this one and this one are the same, so we cancel this one. So this and this one will cancel, so our value will be 2. This one plus this one, the product will be this one 6 plus this and this one cancel. So this is overall for the second reaction. This is overall for the second reaction. So we have to combine this one and the first reaction overall between manganate and the iodide in acidic medium in order to get the general overall reaction or reduction reaction or redox reaction. So net overall reaction between procedure 1 and procedure 2, we have this is overall for the first, this is overall reaction for the second. So we have to combine by this one. What we consider here, we have to look, we have this one and this one. So this will be here and the form will be here. That is how we are going to make the overall reaction. So here we need to this and this one, and we have to with 16 hydrogen ions, react with, which means this one, when you look here, this is 10 and this will be 10. So this and this one will be cancelled. So here we plus this one, we go to the other side, will be this one, will be 10, will be 10. Plus this and this one will be 5. Do you look? This we cancel with this one. And this one will be 5, and this one will be 5. So this and this one also will cancel. So we take this one, the product will be 2 N 4, will be 2 here. Will be 2 plus 5, 6 plus water. Water 8. Be 80 water. So when we look at the product, be 2 manganese oxide with 16 hydrogen ions, 10 thiosulfate. The product is this one and that one. So the molar should be is 2 per 10, or you can say this is 1/5. That is the molar ratio. That is the product or the overall reaction when you meet with the question with the potassium permanganate, sodium sulfate, potassium iodide, starch, and the sulfuric acid. I think that is the end of this lesson. Thank you for learning through this. I think you have understand.